Thank you for introduction. Good afternoon. My name is Sungchul Jung. I'm working at the HIT Lab in New Zealand as a postdoc. I'm happy to give a presentation about our research. The title is Redirected Jumping, Perceptual Detection Rate for Curvature. I'm going to give a talk with this order. Traveling in virtual environment is a fundamental aspect of experiences in virtual reality. Though most VR experiences can provide almost infinite space to explore, there are many constraints such as limited physical space and limited tracking area. To address these problems, researchers have suggested several locomotion metaphors, for example, teleportation, joystick-based locomotion, or walking on a treadmill. These techniques are device-based. On the other hand, other researchers have suggested gesture-based locomotion metaphors such as walking in place, trigger walking, or redirect walking. Since real walking provides the most natural method for locomotion in VR, researchers have investigated various aspects of redirect walking techniques. Redirect walking manipulates the user's orientation by injecting rotation during walking, so the user walks on a straight line in VR, but while actually walking along a curve in physical space. To estimate the physical space needed for infinite virtual walking, studies of redirect walking have estimated the maximum possible gain without the effect being substantially detectable. Staining reported that subjects could be shifted by 13 degrees per 5 meters over walking unknowingly. After the user walked in VR, they were asked to choose if they felt their direction was curved to left or right side. This would theoretically allow the user to walk infinitely along a circular arc over a radius of at least 22 meters. However, 22 meters by 20 meters is still big large space. So, a smaller space is needed to utilize redirect walking. In this paper, to address this limitation, we proposed jumping as a supportive metaphor for locomotion. Because jumping is a natural behavior, and the jumping could make a significant vestibular noise, and we guessed this might produce more curvature gains. So we call this redirected jumping. Redirected jumping is a relatively new idea. In 2019, Hayashi reported on the impact of redirected jumping in terms of rotation, height relocation, and translation. And they found significant positive effect of jumping in a VR. However, they conducted only one-time jumping. Along with Hayashi's research, in this paper, we investigate the effect of redirected jumping using multiple jumps along a curve to address our research question. That is, do multiple jumps decrease the perceptual detection rate for curvature gains compared to redirected walking? To investigate the effect of redirected jumping compared with prior redirected walking researches as directly as possible, we followed a similar experimental method as conventional redirected walking. So, we designed the study with two alternative forced choice, which means the user will only choose at either left or right after they doing jumping in the task. We set several parameters based on staining research. Since jumping can induce physical fatigue, we limited the distance to 3 meters and 4 jumps per trial. Also, we expected jumping would induce more curvature gains in redirected walking, which was a plus minus 0.045. So we set higher gains of 0.04, 0.07, 0.1, and 0.13 compared to the previous research. We coded the 4 gains as very low, low, middle, and high that map to the 4 curvatures as well. This slide shows our experimental setup in the virtual environment. We landed the virtual pillar in the middle of the sea and provides only sneakers and the spear to the user for confirming their location with ambient sea sound. Each participant was asked to jump from the initial point to the end point and asked to choose which direction they were bended. We divide the jumping phases into 5: idle, ready, up, down, and landing. We inject the gain based on the equation using angular velocity times predefined coefficient for each jumping phases. We decided those coefficients during a pilot study before we are running actual study. To prevent too fast continuous jumping, we displayed one pillar at a time while the user was jumping in the air. If the user stayed on a platform for more than 1 second, we categorized the jumping as a discrete jump. Otherwise, we defined it as a continuous jumping. To reduce a confounding variation in jumping type, we verbally asked the participant to do more vertical jump rather than broad jump. But we did not limit their stepping type or arm swing. So we just represent how they did actually through the table. In this study, a total of 15 participants was involved. We used to use 5 Pro HMD with 2 controllers and 3 additional trackers on both feet and on the waist. As explained, the user had multiple jumps on a straight path. The user's redirection was tilted either left or right angle, as you see the white lines. In the study, we measured detection rate and the level of cyber sickness. This is our procedure, how we conducted the study. To prevent any physical harm, we screened the participant health condition first. After that, they signed an informed consent. After filling out the demographics, we asked the participant to fill out pre-SSQ and gave a training session. In the session, the participant was instructed how they should jump and how to give their answer using the controllers. After they confirmed the process, we conducted the first trials. At the initial platform, the participant confirmed when they were ready to jump by pressing the right vibe controller trigger, and they were asked to select which direction they were curved using the touchpad of each of the controllers. Then they were asked to step back to the initial point and guided by the experimenter for next jump. Each participant had 16 trials, which makes a total of 64 jumps. After that, they were asked to fill out post-questionnaire and finish the study. All takes about 8 minutes, 30 seconds. Here is the video, how we did. So this video shows that the left side is we render the first-person perspective, and the right side renders third-person perspective. And each participant can confirm their location when they see their feet and then the spear in the middle. After that, when they reach to the end of the platform, they have to choose they were bent left side or right side. After that, the experimenters guide them back to the initial point. And we repeat this jump 16 times. So this is how actually the participant did. So it looks like a little bit, scary, but actually to prevent any physical harm or collision, we had 2 experimenters. So other experimenters observed how participants did and watched their behavior just to prevent any physical harm. Here is the result. In redirected locomotion studies, it is standard to fit responsive detection rate to a bipolar sigmoidal function for estimating detection threshold. We plot the mean probability for the responses that the physical path was curved to the left against the curvature gains at the level of 25% to 75% probability range, which is represented with a gray color, which is conventional ranges. Surprisingly, subjects responded in an even smaller probability range between about 35% to 60%, which is represented with a red color area for all curvature gains. However, the results staying well below the threshold that did not cover a range for clear fitting to the psychometric curve. But more importantly, the deviation from the threshold in the middle blue line to the older plotted value is not large, which means the users had difficulty to detect the angle was shifted. Our result shows that gain has about 3 times higher compared to previous research. In our result, we suggested that redirect jumping in VR could induce much higher detection threshold above our highest gain of 7.5 degree per meter. The pre-SSQ score average over all subjects was 1995, and the post-SSQ score was 29.17, and this indicates that we didn't find any serious cyber sickness from the redirected jumping. In the study, we observed how detection rate, a low detection rate for redirect jumping overall, and we conjectured that high vestibular noise was induced from the jump, as we hypothesized based on the 2 observations. The first one is the user adjusted their orientation after the jumping. And the second one is it seems that users were unconsciously or unaware the rotation had been injected artificially. Therefore, we can suggest redirect jumping as a supportive locomotion metaphor in VR. For example, we could apply redirected jumping for going up or going down step that could be more dynamical locomotion option and in gaming scenario like a fitness application. However, we should consider safety issues such as collision or physical fatigue. Here's our conclusion. In this presentation, we introduced the effect of the redirect jumping with multiple jumps on a curvature. We found that the detection rate was about 3 times higher compared to Stanik's research, and it could even higher since we did not find the upper threshold for it. As a future work, we will research on the effect of the combination of redirected jumping in a place or just jumping gesture. Also, it will be very interesting to work on the combination of the redirect jumping with redirect walking in VR. Thank you.
Great. We have some time for questions. So any questions from the audience? Last session at UIST. If you want to ask questions, now's the chance. All right. Well, while everyone is thinking deeply about the talk that we just saw, I'm wondering if you could talk a little bit more about how you think sort of basically on one end there's walking, on the other end there's sort of the jumping that you were doing.
Yep.
What do you think about this continuum between jumping and walking? So for example, skipping or other like large steps, how do you think these types of things can be affected by the same principle, and have you thoughts about that?
Yeah, that's a good question. Thank you. So basically, this research focused on we wanted to find some threshold, how the detectable threshold. So for the reason we want to investigate if when we're doing the jumping like this, then our hypothesis was this jumping will induce more vestibular noise. So the participant, the users will have a difficult to detect their direction. This is the basic idea. But as he mentioned, actually the final goal is how we're going to make a combination with a redirected walking and the redirected jumping. And then not only even for redirected walking, redirected jumping, we are also looking for the combination with walking in place, which is just a gesture-based locomotion technique. So we don't need to go this side, just doing this gesture in a place. And with some combination with this kind of a gesture-based locomotion with the redirect jumping, then we would expect it will give some more dynamical locomotion techniques. So that is that answer for you?
Yeah, thank you very much. Any questions from the audience?
Have you tried, I'm just thinking jump is sort of fast motion. Maybe you can use it in the narrative to blur what you actually see and maybe use that for even larger angular rotation of the mapping.
Can you say again, please? Yeah.
I mean, you looked at jumping the same way you looked at walking.
Yeah.
But jumping is a very weird action, and you can use it for the narrative, for example. Maybe your cameras are blurring as you jump, and maybe you can get away with more angular rotation.
Yeah, I agree with that. Actually, in the video, maybe somebody could notice that after the actual participant doing jump, oh, sorry. And during the time, they adjusted their headset because of the jumping behavior makes some loosen the headset. So that is a kind of a limitation at this moment. But still, we thought about that. Even though we don't need to do this actual jumping, maybe we could do this kind of a gestures, just a flexing position. But actually, we don't want it to spoil, but actually in our lab, we're doing this kind of studies as well. And we found that this one also possibly provides some similar effect. So we can maybe tweak the idea a little bit. Yeah.
Great. So we have time for one quick last question while Jackie sets up, if there's one from the audience. Okay, well then I have a question about how do you, so in the study that you showed, you said that you didn't exactly control for how far a person jumps. How much do you think basically, so you controlled the different gain conditions?
Yeah, right. We control the different gain conditions, but the gain is only for the angle, but we just fixed the distance. The translate distance was fixed about 35 centimeters.
And so you trained people to jump 35 centimeters, or
we didn't train them, but we gave the trial session, and during the trial session, participants could notice that how much they will do jump. But we verbally asked the participant do more vertical jump rather than broad jump. Yeah.
Don't jump here. Yes. But let's thank the speaker again.